quadratic equation in the variable x is an equation of the form ax square plus bx plus c is equal to 0, where a, b and c are real numbers and a is not equal to 0. Here is an example of quadratic equation. 5x square minus 3x plus 3 is equal to 0. This power 2 of variable x makes the equation quadratic. The name quadratic comes from quad, meaning square, because the variable gets squared like x square. But sometimes a quadratic equation is not in its usual form. This is a quadratic equation in disguise. Move all terms to left-hand side and you have the equation in the standard form. In standard form, the equation is x square minus 3x plus 1 is equal to 0, where a is equal to 1, b is equal to minus 3 and c is equal to 1. Next quadratic equation in disguise is 5 plus 1 upon x minus 1 upon x square is equal to 0. Multiply by x square on both sides, and here we have the standard form. 5x square plus x minus 1 is equal to 0, where a is equal to 5, b is equal to 1 and c is equal to minus 1. Represent this situation mathematically. A cottage industry produces a certain number of toys in a day. The cost of production of each toy in rupees was found to be 55 minus the number of toys produced in a day. On a particular day, the total cost of production was rupees 750. We would like to find out the number of toys produced on that day. Let's represent the given situation mathematically. Let the number of toys produced on that day be x. Therefore, the cost of production in rupees of each toy that day is equal to 55 minus x. So, the total cost of production in rupees that day is equal to x into 55 minus x. Therefore, x into 55 minus x is equal to 750. This implies 55x minus x square is equal to 750, which implies minus x square plus 55x minus 750 is equal to 0. Multiply both sides by minus 1. This gives x square minus 55x plus 750 is equal to 0. Therefore, the number of toys produced that day satisfies the quadratic equation x square minus 55x plus 750 is equal to 0, which is the required representation of the problem mathematically.